So next, we're going to work through some problems to find probabilities where two dice are tossed. So to start, we need to figure out the number of things in our sample space when we roll two dice. Here we can see we have the sample space already listed out here with the table of the red and the green die. And we know from our counting principle from 7.1 that when we know our number of options for each individual stage, we can just multiply those together. So the red die has 6 options, and the green die also has 6 options. So we can multiply those together, and we get that there's 36 different outcomes that we could have when we roll 2 die. That is our number of things in the sample space. If we counted them all up here on the table, you would see that you would also get 36 from that as well. So now for part A, we are asked to find the probability that the sum of the 2 dice adds to 7. So my first thing that I need to figure out here is my number of elements in the sample space that add to 7. Because we're going to need that to be able to figure out this probability. So if we take a look over on the table on the left, if we start with the bottom left corner one, 6 and 1, those will add together to get 7. We also have 5 and 2, 4 and 3, 3 and 4, 2 and 5, and 1 and 6. So we have 1, 2, 3, 4, 5, and 6 different outcomes in our sample space that will add to 7 when we add the 2 dice together. So our number of elements that add to 7, well, there's 6 of them. So now our probability that the 2 dice will add to 7, well, that's going to be equal to our number of dice that add to 7, which we found as being 6, over our number of elements in the sample space, which is 36. And now 6 over 36, that can be simplified to 1 over 6. So our probability would be 1 over 6 of the chance of the 2 dice adding to 7. Next, we want to find the probability that the sum of the 2 dice add to 11. And that's a higher number, so there's not as many of those that they'll add to 11. We have 6 and 5, and 5 and 6. So our number that add to 11 is equal to 2. So then our probability that they add to 11, well, that's simply just going to be 2 over 36, which that can simplify to be 1 over 18. So now, lastly, we need to find the probability that the sum of the 2 dice add to an even number. So I'm going to erase my highlighting that I currently have on the table, because now we need to find all of our dice that add to an even number. So let's start off with, we have 1 that adds up to 2. And then we have 1, 2, and 3 that add up to be 4. And then we have 1, 2, 3, 4, and 5 that add up to be 6. And then for 8, we have 1, 2, 3, 4, and 5. wrote some wrong numbers down here, but we had 3 that add up to 4 and 5 that add up to 6. And then we have 5 that add up to 8. And then we have 1, 2, and 3 that add up to 10. And then we have one option that adds up to be 12. So if we add all these together, we have 18 different outcomes from our table that add to an even number. So now our probability that they add to an even number, well, we have 18 from the table out of the 36 different options. So then that simplifies to be 1/2, or 0.5. So now, the last thing with this, both of the examples that we've done, the rolling 1 die, the rolling 2 die here, these are examples of what we call theoretical probability. It is using our knowledge of our equation of the probability that the number of things in the event divided by the number of things in the sample space is the probability of this happening. It's very much also based on the fact that each outcome is equally likely. We're relying on that theory that the chance of any one outcome on that die is going to be the same as any other outcome. In the next video, we'll look at empirical probability, which is more based off of data that is given to us through research or surveys and things like that.